Okay, so generalist, specialist, this was where I see the magic happening. I won't repeat myself there. And this was the paper that I was referencing. I'm going to try and, can I just check if somebody would unmute yourself? Are you seeing the menu bar at the top of the screen, or are you just seeing my screen?
We only see the screen, so
You're seeing you, yeah, we are seeing your screen.
Perfect.
I mean, your
Okay.
PowerPoint.
Thank you so much. Okay, so back into business here. So this was a paper that really was the one that I mentioned that was pivotal for me, at least, in appreciating the role that nutrition could play, not just in everyday managed care, but because nutrition could be really important in conservation breeding. We were starting to see an increase in interest in using all the captive management techniques, but now apply them more consistently to amphibian species. So this highlight was my own. And just something to point out is that references that I mentioned here, I'll be sharing with Luis, and I think we're generating a pack of references for the series of webinars, so those will be available by the end of the series. So I know for this audience, this may be some repetition of fairly fundamental information, but I think it's important just to call out that amphibians comprise 3 orders. The Gymnophiona, probably not pronouncing that particularly well, Caudata, salamanders and newts, and Anura, frogs and toads. And I will share that I will frequently reference frogs because the bulk of the reference material that we have is for frogs. But I just wanted to acknowledge that there are multiple species in this taxa. And in fact, there's a graph that's going to come up shortly, which is no longer accurate. I believe the number of described species in this taxa exceeds 8,000. So we've got an awful lot of diversity here. And we know that amphibians are in danger. Chytrid is very well described, and the threat of chytrid is very well understood. I'm not going to say chytrid is very well understood, but of course, we're seeing massive swings in climate, huge disruption across the planet. So there are many, many threats that are happening to amphibians. And in 2011, colleagues at Species 360 pulled together a paper that was published, I believe this was in Science, but there was also an article in the WASA newsletter, which was looking at this role that zoos could play in conserving biodiversity. And this graph here shows that the number of species, of the number of species described in zoos, there was a very low representation of amphibia in zoos, and this is the example where at that time the estimates were around just over 6,000, and now this number would be much higher. And then of those species, a very high proportion of species within the amphibian taxon are threatened with extinction or have one of these other categories. But the representation in zoos at that point was very low. So this was presented as an opportunity. So you combine the opportunity to conserve species in captivity with the understanding that captivity could modify nutrition, and captivity could modify the species. And if we're thinking about species for conservation and being able to ultimately release them into the wild, then this seemed an important intersection to compare and start to investigate further and just understand better what we mean about nutrition. So I'm just going to diverge a little bit. This isn't an amphibian, but I don't have any historical pictures of amphibians in zoos. This picture actually comes from the New York Zoological Society, as it was over 100 years ago. But I just want to diverge a little bit and explain the context of comparative nutrition in zoos. And before we get into comparative nutrition in zoos, it's helpful really to think about the evolution of zoos and aquariums, or at least I find it helpful to think about it in this framework. And so this is a diagram from was a conservation strategy, I think published in 2005. And it very clearly describes how zoos have evolved over the centuries, from menageries to zoological parks in the last century, to really positioning themselves as conservation centers, working with partners in the field, really focusing all of their efforts and their abilities into preserving species and being able to share those messages with their visitors. And even very specifically with amphibians, we can think about that conservation activity as being preserving species, much like the ark. And so comparative nutrition comes down to feeding the ark. And when you have multiple species to feed and very few technical resources, I like to break down this task to be into simple questions. So for any specific species, I want to know what feed items I can offer, how much of those feed items I can offer, and why those items are important for that species. So keeping it really simple. And also knowing that when I started in zoos, which is about 20 years ago now, and knowing that actually nutritionists in zoos are still fairly rare, and we have been feeding animals in zoos for many decades before there were nutritionists, not starting from a position of having the diets be poor, but our goal is always there is room for improvement. So we're trying to make diets better. And why do we want to do that? Well, I think most of this would be self-explanatory, but it's worth just emphasizing that we're attempting to maintain or improve health and welfare. We want to understand and improve nutrition for reproduction and long life, and we want to make evidence-based decisions. If we think about that same trajectory or evolution for zoo or comparative nutrition, then over an equivalent time frame, you might think that we've moved from husbandry skills and stockmanship. So that's just a way that I think about this is people who are very skilled at taking care of a particular taxa. So they might be very skilled about looking after birds, so they're aviculturists, or we've got aquaculturists or herpiculturists. But they have a very specific set of skills that really can't be taught. They just have gained them from some kind of intuition, and also just having a relationship with the species that they look after. We move forward into applied nutritional science, and this really came to the fore in the 1950s in relation to animal care, animal science, particularly livestock, and animals that are important for human relationships, and particularly feed animals. And then we move into taking a multidisciplinary approach to understanding how nutrition and husbandry, genetics, and health all combine to improve an animal's lifespan and reproductive success. And I would like to share that this has happened over that same time frame. But I think the reality, for me at least, my perspective is the reality is that we're still very heavily skewed towards relying on husbandry skill and stockmanship. There is some applied nutritional science, and when there are specific health issues, we move into this multidisciplinary approach, and I think you'll hear some of those examples over the coming seminars. But it's not going to be a surprise, I think, to this audience that really when we think about lower vertebrates in particular, and amphibians would fall into this category, we're still very heavily reliant on husbandry skill and stockmanship. And so one of the pleas that I would make for anybody in the audience is being able to translate that knowledge that you have or experience that you have, and you're maybe making decisions about, well, I see changes based on feeding a particular way or with a particular set of environmental conditions, translating that skill into empirical data that we can use and share with others. I love this quote. It's actually from a book about wild mammals in captivity, but Deborah Kleiman, when she's introducing some papers about nutrition, which I think are great standard text, even though they are written with mammals in mind. She writes that unless and until zoos can replicate the exact seasonal, temporal, spatial, and nutritional complexity of diets encountered in the wild, animals are faced with choices they have not evolved to make. We must make their dietary decisions, and our challenge is making the right choices. So that's really the challenge for many species. And thankfully, amphibians are getting a lot more attention now than they once were. But we're still in that situation where there's so much more to learn. So pivoting back to amphibians, and I'd just like to put in really nice pictures every so often just to remind us what we're talking about. I think for me, something that's very important is that these are very familiar animals, often in our back gardens or in our habitats. They're part of folklore. They're very familiar, and yet we know very little about their natural history. And there's also a huge amount of diversity from totally aquatic to terrestrial. And again, in this lecture series, I'm going to touch on a couple of things, but you're going to hear in greater detail from others who have studied species or greater detail. And then there's also this component that they have different diet habits at different life stages. But just, again, something that I find helpful to remind myself is just the range of diversity and dimorphism that we see in species. So for example, they're incredibly diverse. This is a picture, I think, taken in Africa with an example of a Goliath toad on the left, and these can reach up to 30 centimeters as compared with a reed frog, which I think is about 3 centimeters on the right. And then I think, and there may be more current information, but this is an example of a frog I think found in Cuba. I'm not going to attempt the scientific name, but this frog is believed to be the smallest described frog, and it's about 1 centimeter long. So we've got, even within one order, a great degree of size differences. And then, of course, when we move to other orders, we can move up to the giant salamander and increases again. When we're trying to think about adequate nutrition of amphibian, we're striving for normal growth and development. So what are our references for that if these species are very poorly studied? We definitely want to use health as a barometer of adequate nutrition and low mortality rate. And then we use successful reproduction. Remember, these species are in our care because they're threatened in their natural habitats. So we're striving for reproduction, and that means fit and healthy offspring. And I think you'll understand that when empirical data is lacking for a taxon, we need more research, but also we want to determine species-specific requirements. And I make this comment here because something that I think is really critical is to be aware that in fact, we probably shouldn't be talking about requirements. We should be talking about recommendations for different species, and not trying to create a blanket requirement for amphibians. And this next slide might help. But within the comparative zoo nutrition field, we talk about providing recommendations for species versus requirements. One of the reference series that we use is publication series by the National Research Council based here in the United States. And this language is from their own website. All of these books are available. If you log in, I think you can actually get PDF copies, at least page by page, for free. And you can see that they're producing requirements of species that are based on the most recent information and on nutrition and ingredient composition that allow efficient, profitable, and environmentally conscious animal production. And when you look at that series, most of the species that are listed have some role in providing food or some other product that is beneficial for humans. There's two other categories. There's companion animals, so there's requirements for cats, dogs, horses, some small mammals. And then there's another category, which are laboratory animals. And so under laboratory animals, there are actually there's information about primates, rodents, and the main study model for many researchers, for many reasons, would be xenopus. So we have one single amphibian for which we might have some requirement data based on years and years and years of study, but for a very specific purpose. And the reason why I put up a chicken is because my research was in avian nutrition, and the chicken is something that is very well studied. We have great information about chickens, but that chicken there has to do a whole lot of heavy lifting in terms of providing information for many, many other species. In fact, there's approximately 10,000 species of birds. So in comparative nutrition, we will often talk in less definitive terms about requirements, and we are doing informed guesswork based on a very large suite of knowledge, and therefore we make recommendations. The other factor to consider here, and again, this isn't news to this audience, is that we have this really unusual life history where we have a group of animals where they go through this very complex life history after they hatch out from eggs. So we can talk about the larval feeding strategies, and again, I think Amphibian Arc has provided some detailed materials on this topic before, but it's just fascinating to recognize that when we look at species, we can look at their physical anatomy and from their anatomy use that to determine the feeding strategy that they might have, and therefore based on the feeding strategy, the type of food strategy that you might use to rear these different types of larvae. So there's this specialization is happening even at the larval stage. And that translates into then not having a one-size-fits-all way of nourishing larvae from different species. And so then this gets back to that point about needing species-specific recommendations and not thinking about amphibians as one monolithic group that have to be fed the same way. Those, let me just go back, those different categories of mouse are going to be adapted to different categories or groupings for feeding, herbivore, omnivore, and even this egg eating strategy, which I'm sure many of you have seen before, but I always find fascinating. And it just serves to emphasize the challenges here. You're going to hear from somebody later about mountain chickens, but this is a little video clip from the BBC. I think it was recorded at the Jersey Zoo. There's no audio. Oh no, there is audio. And what you're looking at is a female who has multiple tadpoles who have hatched from eggs, and now she's producing a second set of eggs that are food parcels for those tadpoles. So that just presents the challenge of thinking, how on earth do we replicate that? And understand what might be in those egg parcels, because the eggs produced to produce larvae are going to be very different for the ones that are produced to actually feed those tadpoles, those larvae, as they grow. And the nutrient profile is going to be very different. But the quantities involved and also the ethics of removing eggs to actually do analysis, and therefore sort of missing out on actually rearing a very rare species. There's a lot of different things to consider there. Oops, we're going to watch that again. Then if you think about adult feeding strategies, then we know that reptiles are, as adults, primarily, almost exclusively carnivores. There are exceptions to this, which I think other speakers will touch on. But really, we tend to focus on the fact that adult amphibians are carnivores, and so they're feeding exclusively on animal protein. And there's a range of animal protein. These examples of a frog feeding on, I think, a type of bird there, and perhaps even other frogs, are documented in nature, and we have some limited information about what these prey items will comprise and deliver in terms of nutrition. And I'll talk a little bit more about that when I talk about nutrients in the next lecture on Wednesday. But for the most part, we know that we're feeding a very limited set of feeds. We do have some information. This is a great book. These are illustrations from Stevenson Hume, who described vertebrate anatomy. And we know that from the digestive anatomy pictures that have been described, then they are very similar to a carnivore digestive tract, which is a very simple tube from the mouse through into sort of a stomach area, if you could just call it that, where there's going to be some enzymatic digestion happening here. And then there's no differentiation between a small and a large intestine, but this area here, this loop, would be where nutrients are absorbed before any material that isn't digested is excreted. But in terms of understanding wild prey species, again, there are, where they have been studied, the list can be pretty extensive, and you can get a lot of variety described for any particular amphibian that has been studied. But oftentimes the way that this is determined is through stomach contents. So it's largely opportunistic. And I know in one study where that I was involved in, one of my PhD students was trying to understand diet diversity over time, and the population that she was studying were, when they were in reproductive mode, the males weren't eating. So there was a lot of variability in what you might be able to sample. And then what you're getting in stomach contents is digestive material. So the ability to actually then determine the nutritional content of those items and what the frogs or the amphibians are benefiting from those items is hard to understand. It's not possible from stomach contents. So that means that we don't have a lot of information on nutrient composition of prey items. But it's likely that wild prey are nutritionally superior to captive reared equivalents. And we already know, and there will be a separate lecture specifically about the nutrient content of invertebrate prey. So I'm not going to touch on that too much here, but we do know from feeding invertebrates and zoos generally that nutrition of these items, there tends to be a mineral imbalance and skewed in favor of phosphor versus calcium, which is something that usually needs to be addressed. The vitamin levels are low, and you'll be aware, and there's a separate talk, that there's a big interest in the carotenoid content of those insects as prey items. There are better pictures out there of the range of prey items, but it is, I think we can all recognize that what we can get from our zoo supermarkets in terms of prey is very limited. And the main point is not only the limitation of those prey items and the fact that there are so few species, is also the fact that they're mass produced. And you can circumvent this a little bit by producing your own live feed colonies. But as I think you'll hear from other people, that there's a lot of effort that goes into that, with no absolute guarantees that you're producing better quality, better nutritional quality of food item. And so whether it's bran or some kind of pelleted meal, you have this trade-off between being able to produce insects that are going to live and survive and maintain your colony, against the actual nutritional quality of their base diet. And so this is something that I don't think anybody in the zoo community has completely resolved. And it doesn't only apply to amphibians, but given the dependence of amphibians on invertebrate prey, of course, is vitally important. And something else that's a factor here is, I don't know if other people experience this, but I think this limited range of prey items now in sort of a post-COVID world, and I mean that in the sense that now that we've had COVID and a pandemic, supply chains are forever changed. And so in 2020, there was a shortage of different invertebrates in the US. Some of it was national. And never thought I would say there was a national mealworm shortage, but there was. Some of it was localized, but it was related to multiple factors, including some colony die-offs and the availability of other raw materials in the feed chain. So these are things that we have to factor in as we think about managed feeding programs. And then just, I think the point will be made by others, but it's worth highlighting here as well, is that we don't fully understand all of the different insects or invertebrates and prey items that are being consumed. But we know it's diverse and varied. It will be affected by seasons. And many of these prey items, and I just picked out invertebrates specifically rather than fish or birds or other groups, but many of these food items are, or these prey would themselves be feeding on green plant material, which in itself is providing different nutrients to the invertebrates so that they can grow and develop, and that's going to change seasonally and affect their nutritional profile so that they can go through their various life stages. And one example, I was involved in a very short study with Dr. Andrea, and we were able to look at silkworm larvae, and we looked at proprietary larvae that we purchased that had been fed on just a bran-based diet, and then compared that against silkworm that were reared on mulberry leaves, which is much more intensive, so you don't have the same yield. But what we were able to demonstrate in that very short survey was that we had much higher levels of calcium. The calcium to phosphorus ratio was much more appropriate for mineral balance. So it was closer to a 1-to-1 ratio. And there was something like 100-fold difference in the level of vitamin E, which was entirely attributed to the tocopherols that would be present in the mulberry leaves. It couldn't come from anywhere else. So we have this expectation that when we're feeding insects and using prey items, that we're going to have to do some kind of augmentation to improve the nutrition of our species. And I think you're going to hear more about that in other lectures. And there are definitely there's a lot of investigation in this area, so I won't do that justice here today. And then there's this example of, even if we were to bring prey species into situations where they could be propagated, it's not necessarily the case that we would entirely replicate their nutritional composition, because it's not only the nutrition, it can be other compounds that are present which are important. There can be this relationship between them. So I just offered this example of the idea that the poison in poison dart frogs is due to alkaloids that are present in beetles, but based on what the beetles are eating in their natural habitat. So propagation of those beetles outside of that habitat without those plant materials doesn't reduce in this, it doesn't result in the same production of alkaloids, which then of course would not be passed on to the dart frogs or the birds which would consume them. This is only here to note that there is so many more things that go into feeding strategies than just simply nutrients. So there's seasonality, activity and behavior, and also looking at your management, thinking about stocking density, and recognizing, again, going back to behavior, that the strategy that species employ, whether they're actively foraging versus being an ambush predator, will actually play out and be important for how much you might want to feed them. And we'll come back to that in a second. There's another presentation which is going to talk in more detail about health and some of the common issues that we see. But there's non-specific failure to thrive or ain't doing right. Then other instances here, metabolic bone disease, renal calculi, both believed to relate to mineral imbalances. Steatitis, corneal lipidosis are related to that predominantly. Thiamine deficiency will occur when you don't take account of the thiaminase activity that happens when you defrost fish. So it's a very specific instance there. Thiaminase is an enzyme that is present when animals decompose. And actually, when you start to thaw frozen fish, you restart that decomposition process. And amphibians will be particularly sensitive to it. And obesity, I think, relates to what I was just saying before about that feeding strategy. If you've got an ambush predator who doesn't know when its next meal is going to come along, if you keep feeding, it's going to keep eating. So it's going to be really important to know what your species should normally eat and be very responsive and make those observations about know what a wild animal should look like. In this instance, this animal should have far more wrinkles. It shouldn't have expanded so that those have disappeared, or look like this. So that knowledge of animals and what they should look like is also critical. And then just something on spindly leg syndrome here and the relationship with nutrition. When first talking about amphibian, was asked about the role of vitamin B12, and I found this abstract from, I think it's from 1989, but there's a reference to this, which is, and I'm pretty sure you won't be able to read it, but it's an induced development disorder of limbs and motor neurons when fed a diet consisting only of yeast. So these researchers using xenopods were able to induce limb defects similar to spindly leg syndrome, feeding a highly specific diet that it was deliberately restrictive in nutrients. And so from this and other papers, there was the suggestion that nutrition was key to understanding spindly leg syndrome. And then this picture is actually from another paper in 2018, which was inconclusive, but again started to tease that out, but also look at the effect of water quality. And I'm sure there are many other publications, but fast forward to a paper from 2021, and serendipitously, these authors found a combination of vitamin supplementation, larval diet, and water quality, and the filtration of water and the minerals in the water seem to hold the key to arresting some of the spindly leg issues that they were seeing in the population of frogs. So now we start to get into sort of, it's nutrition, but it's also water quality, and it's that bimodal life history. All of these factors, this kind of multifactorial, multidisciplinary approach that starts to help us understand and improve our nutritional care. I'm going to talk a little bit more about nutrients, energetics, and metabolism at the beginning of the next seminar on Wednesday. So I'm not going to touch on that today, but I do want to emphasize just in closing that it's incredibly challenging to formulate captive diets based on existing fieldwork data. And truthfully, that applies to very many taxa, because you get a list of what is being consumed at a particular point in time in a particular location without knowledge of the quantities or the composition of those items. but I think you can appreciate that this especially applies to amphibians, and particularly when, as I've said, we have so few food items that we can offer. We want to make those the best they can be. So we want to kind of match them to something. And that data doesn't exist. We do know that the prey items are limited and that we have not only a limited variety, but also quality. And I think increasingly we have to take account of the supply issues that mean that this places amphibians and other insectivorous species into a really risky scenario. I think in terms of our success, if we're really trying to judge success, future successes, we're going to need multi-generational breeding, not only at one facility or with one population. We need multiple populations, and we need to look at how those animals grow. Are they growing correctly? Not too fast, not too slow. How do they manage parasite loads? What is the reproductive output? And something that I'm not sure we'll cover in the course of these seminars, but we're also starting to understand that for amphibians, their microbiome externally on their skin, those cutaneous bacterial communities could be really critical for their health and survival. And I think it seems reasonable to me that we're going to need several model species. So using Xenopus for all amphibians doesn't seem to be sensible. But what would be those species? And that's again where there are likely many specialists in the audience who would have a better handle on that. I want to come back to that slide that I started with the steelhead trout, which was from 2007. And so in 2018, these authors looked at 44 species of vertebrates, fish, birds, and mammals, and found that there is this effect of birth origin on reproductive success, and that it's actually, there's a decrease that happens in relation to offspring survival and offspring quality. They do call out that the largest effects are seen in commercial agriculture. That's the section highlighted relative to conservation or laboratory settings. I would hazard a guess that actually agriculture has been happening and established for far longer than many of our amphibian programs. So I think this kind of concern, or at least something that we should pay attention to, still holds true. And particularly when we also look at an updated paper. This was, if you remember, the data from ZIMS was from 2011. This analysis published in the International Yearbook took data from ZIMS in 2017 and looked at a number of different things, but this was the graph that I thought was really worth sharing today, and looking at the number of animals that are, GTS stands for globally threatened species. So of they split it into globally threatened species. There are still far fewer of those maintained in zoos than non-globally threatened species. So we're still, although we have made huge inroads into diversifying the number of amphibians that we care for, we still have far more species in our care that are not globally threatened, versus the other two categories, globally threatened or no data. And in every instance, there are very few that are breeding. So I think this is also a role where thinking about nutrition, having this series is really, really timely, because it's clear that there's more that we could be thinking about and working on. The authors give multiple reasons for this. Some of it's because simply the animals aren't in they aren't matched with animals that would allow them to breed, but part of it is about knowing what those conditions might be, and nutrition is a component of it. I've been involved in supervising and supporting some research which shows that food, fitness, and fertility are linked. We looked at, specifically, we looked at carotenoids, we looked at calcium and the controlled provision of ultraviolet light, and also the nutritional composition of some of those feeder invertebrates. And there are some other authors who are going to talk a little bit more about those topics. But what the takeaway for me was, it was totally possible to do these very robust studies over several generations in a zoological setting. And so I would just before I close, I would like to sort of offer that a great resource, if this is something that you're interested in and want to pursue, is the BIAZA Research Committee produced a handbook which outlines how to do robust science in zoos and aquariums, and it's a great resource for zoos, but also for research academic groups who want to work with zoos. And it's kind of a how-to guide, not just of the science, because a lot of that already exists, but just we're a very particular group to work with, and so it walks you through all of that. So I would encourage people who are interested to read that, and I'll make sure that's part of the pack that goes to Louise. But with that, I'm going to stop, and I think we've maybe got a minute or two for questions, but as I said, very general introduction to this topic, and hopefully laying the foundation for the talk.